All right, in Unit 11, we're going to start looking at some angle measures and area of polygon. So the first thing we're going to do is angle measures, and this is something that we've done in class before. So our first theorem is the polygon interior angle theorem. So the sum of the measures of the interior angles of a convex, meaning that all of the vertices point outwards, of a convex polygon is 180 times n minus 2, where n is the number of sides in the figure. And so we have a corollary here, which means that it gets more specific. So the measure of each interior angle of a regular n-gon, and so regular means that all of the sides are congruent and all of the angles are congruent. So if it's regular, then the measure of each interior angle is that angle sum divided by the number of sides. So each angle is going to be the same. So we take the angle sum and we divide it by the number of sides to find the measure of one interior angle. So this other equation down here is just how you solve it. And I prefer to set it up as an equation and solve that way instead of trying to plug it in here. So the next theorem is the exterior angle sum. So the sum of the measures of the exterior angles of a convex polygon with one angle at each vertex is 360 degrees. So no matter what polygon you're working with, the sum is going to be 360 degrees for the exterior angles. And then the corollary for this one is that the measure of each exterior angle of a regular n-gon is going to be that 360, which is the sum of the exterior angles divided by the number of sides. And so again, a more specific version of it, but I prefer to set up the equation and solve each time. So we're going to look through a few examples. So for example 1a, we're going to find the sum of the measures of the interior angles of this polygon, and then we're going to find the value of x. So to find the interior angle sum, we need to know how many sides there are. So I like to remember where I start from. So this is 1, and then I'm going to count my way around. So this one has 6 sides. So this is a hexagon. So to find the interior angle sum, I'm going to plug 6 into that formula for n. So 180 times n minus 2, and the number of sides here is 6. So that's 180 times 6 minus 2. So 6 minus 2 is 4. So I'm going to do 180 times 4, and that tells me that the interior angle sum of this hexagon is 720 degrees. So now I'm going to find the value of x by setting up an equation. So I need to add up these angle measures here. So I have two 90-degree angles. I'm going to go around and I'm going to add up each angle. So 90 plus 135 plus 135 plus 90 plus 120 is going to be 570. So for the interior angles of this hexagon, that's going to be x for that sixth angle, x plus 570 equals 720. Now subtract 570 from both sides. I'm going to do 720 minus 570, and I get 150. So the value of x here is 150. So the interior angle sum was 720, and the value of x was 150. So the next one is going to be the same directions. We need to find the angle sum. So first I'm going to figure out how many sides this figure has. So that's 1, 2, 3, 4, 5, 6, 7, 8 sides. So 8 is the number I need to plug in. So 180 times 8 minus 2. And 8 minus 2 is 6. So I'm going to do 180 times 6. And that is 1080. So the angle sum for this figure is 1080 degrees. And then I'm going to find the value of x. So I'm going to add up these other angles. So this is 125 plus 130 plus 125 plus 135 plus 135 plus 125 plus 160. I'm just going to bring this out here and make sure I typed in all 7 of those numbers, and I did. So the sum of those angle measures is 935. So this equation will be x plus 935 equals 1080. So I'm going to subtract 935 from both sides. And 1080 minus 935 is 145. So the measure of x, or the value of x, is 145. So again, same directions. First we have to find the angle sum. So this figure has 5 sides. So when I plug that into the formula, I do 180 times 5 minus 2, which is 3. So I'm going to do 180 times 3, which is 540. So the interior angle sum of this figure is 540 degrees. I'm going to set up an equation to solve. So here I have two things that have x's in them. I need to combine those. So 4x plus 3x is going to be 7x. Then I'm going to add up those other three angle measures. So 112 plus 115 plus 82, which is 309. So 7x plus 309 equals 540 degrees. So now I'm going to subtract 309 from both sides. And I'm left with 7x equals, and then I do 540 minus 309, which is 231. I'm going to divide both sides by 7. And 231 divided by 7 is 33. So the value of x here is 33. So now that I've answered those questions, I'm ready to move on. So now we're going to start using the corollaries. So in example 2, here we're given the measure of each interior angle of a convex, or of a convex regular polygon. So all of those sides are the congruent and all of the angles are congruent. So each angle is 156. So that 156 comes from the total angle sum, which is 180 times n minus 2. And then I take that and I divide it by the number of sides. So now to solve this, the first thing I need to do is I need to get this n off the bottom. So it's being divided by n. I'm going to multiply by n on both sides first. So that leaves me with 156n equals, and then for this top part, I'm going to go in and distribute. So I'm going to multiply both of those things inside by 180. So that's 180n minus 360. So to find n, I'm going to solve this equation. Since the n is on both sides, I need to get those together. So the way I'm going to do that is by subtracting 180n from both sides. And whenever I do that, I'm going to do 156 minus 180, which is a negative 24. So I have negative 24n equals negative 360. Then I'll divide both sides by negative 24. So negative 360 divided by negative 24 is 15. So the value of n here is 15, which means that this figure has 15 sides. So if you have a interior angle measure, that's when you're going to use the corollary of corollary of theorem 11.1. Yes. And we use that angle sum over the number of sides. So the next example here is that we're given an exterior angle measure. And the exterior angle measure, we're going to take the exterior angle sum, which is 360. We're going to divide that by the number of sides. And that's going to give me the measure of that exterior angle, which is 40. So on this one, now I'm trying to figure out what n is, but it's on the bottom of the equation. So I'm going to multiply both sides by n. So I have 40n equals 360. And I'm going to divide both sides by 40. And n equals 360 divided by 40, which is 9. So n equals 9. And that's what we were looking for. We were looking for the value of n. So what you might notice here is that since the n is on the bottom, it's kind of like these things are cross products, and cross products can switch places in ratios. So that's how we ended up solving it, was by doing 360 divided by 40. So if we look back at that corollary 11.2, notice that the solving part just had it switching these two cross products. So these two cross products can switch places, and n is 360 divided by the measure of that exterior angle. So that's another way that you can solve a problem where it gives you the measure of an exterior angle.